On the morning of December 24th, the instruments didn't blink, but the trajectory did. Across every observatory feed, 3i Atlas had just passed Earth. The tail was still glowing, plasma jets still whispering, and the anti-tail had begun folding back in. It looked like a retreat. But then something changed. Within hours, a new pattern emerged. A curve. Not toward the void, but toward mass. A gravitational turn toward Jupiter, and not just any path. This one was angled, deliberate, folding across the plane of the solar system like a skipped note in a silent song. The telemetry didn't lie. Neither did the orbital simulations. What 3i Atlas just did was not a drift, it was a correction. And the destination, the largest planetary body in the system, the king of storms, the one object powerful enough to redirect anything, or hide something. In the quiet of that December morning, one realization settled across the space-watching world. This wasn't a passive flyby, it was a waypoint. And from this moment forward, everything has changed. The plans, the models, the assumptions, and perhaps our place in the story. Something subtle happened on the morning of December 24th. As most astronomers reviewed the routine telemetry after the Earth flyby, the trajectory map for 3i Atlas began to redraw itself. Barely, at first. A fractional angle shifted. The outbound arc deviated from prediction, but this wasn't noise. It wasn't thermal drift or gravitational bleed. It was a clean pivot. One that had occurred silently, without any fanfare, just beyond Earth's orbital range. And its new destination? Jupiter. To understand how significant this is, you have to step back and look at how objects move through space, especially interstellar ones. Most comets don't change direction after Earth flybys. They slingshot, yes. Their speed increases or decreases slightly depending on their orientation. But the path is still governed by gravity, solar wind, and known physics. What we saw here was none of that. It wasn't a chaotic spin or fragment ejection. It was curvature, controlled, measured, like a satellite executing a mid-course burn. And yet, this is no satellite. 3i Atlas is still officially classified as a comet, albeit an interstellar one. A dirty snowball from beyond our solar system. Except dirty snowballs don't pivot toward gas giants days after passing Earth. The deviation was small, less than 1 degree at first, but over millions of kilometers, that translates into a shift of hundreds of thousands of miles. Enough to change its entire rendezvous point, enough to bypass the outer belt entirely and draw it straight into the orbital plane of Jupiter. And what made it more unsettling wasn't just the trajectory. It was the data that came with it. The jet, the same jet that first defied expectations near the Sun, had remained active. Amateur astronomers in Argentina and New Zealand tracked it in long-exposure photography and noted that the outgassing vector had not changed. It was still sunward, still functioning like a retro thruster, except this time the course alteration matched the exact vector predicted by its continuing push. This wasn't just sublimation. This was guidance. And the timing? Perfectly symmetrical. The acceleration began after the Earth pass. Not before, not during, after. Like a ship completing one leg of its journey before initiating the next. There were no secondary jets, no visual signs of fragmentation or chaotic spin. The object maintained full orientation, tail intact, coma stable. That's not how comets behave after a planetary encounter. NASA's JPL trajectory models updated within 36 hours. The update wasn't headline-worthy, not yet, but for those watching the orbital telemetry, it said something loud and clear. 3i Atlas was now heading toward Jupiter. Not loosely, not on a natural spiral outward, but with unmistakable purpose. The projection placed it in line with Jupiter's orbital plane within the next several weeks. If you were planning to stage a maneuver deeper into the solar system, or use a planet as a secondary gravity well, this is the corridor you'd choose. And if this object had already survived the Sun, brightened in defiance of thermodynamics, and retained a directional jet past Earth, then this next move starts to look less like comet physics and more like flight planning. That's where the tension begins, because if it's moving toward Jupiter with intent, then we have to ask, what happens next? Is this a refueling stop? A redirection towards Saturn? Or is there something around the gas giant, something we haven't seen yet, that 3i Atlas is targeting? Either way, the story doesn't end with Earth. It begins again, this time in the shadow of a planet large enough to hold dozens of moons and a magnetic field powerful enough to distort everything around it. And now, something interstellar is heading straight into that field. There's a reason Jupiter holds the title of the solar system's king, not just in size but in influence. It's more than just the largest planet. Jupiter is a force field, a boundary, a gravitational wall and a magnetic heartbeat all at once. Its mass is so great that if it were just 80 times heavier, it would have ignited into a star. And while it failed to cross that line into fusion, what it became instead was something just as powerful, a planetary magnet with the ability to reshape space itself. This is where 3i Atlas is heading now, and that alone changes the equation. For most natural objects, a drift toward Jupiter is uneventful, a gradual deceleration, a long arc toward the outer planets, then a quiet slide into deep space. That's what thousands of comets have done before, but this object is not behaving like them. It's not drifting, it's responding. Jupiter's magnetic field is 14 times stronger than Earth's. Its magnetosphere stretches across nearly 7 million kilometers on the sunward side, and trails out behind it in a tail that stretches as far as Saturn's orbit. This magnetic domain isn't empty, it's charged, saturated with plasma from its volcanic moon Io, wrapped in radiation belts that rival any man-made collider. And inside that invisible field, particles don't just float, they spin, accelerate, discharge. Energy flows here in complex chaotic patterns. To enter this zone is to walk into a charged labyrinth, one that interacts differently with different kinds of matter, especially if that matter is reactive. If 3i Atlas is, as the data increasingly suggests, more than a passive icy body, if its surface is conductive, if it has directional geometry, if it responds to electromagnetic fields, then Jupiter is not just a waypoint, it's a catalyst, a trigger, a location capable of activating dormant behavior. And right now, the trajectory intersects that very space. Back in October, we saw how 3i Atlas reacted near the Sun, not just with heat, but with symmetry, a brightness spike, followed by a perfectly timed course adjustment, followed by silence. As if the object didn't simply endure the Sun's radiation, it leveraged it. Jupiter presents a different kind of test. Here, the variables are not solar, they're magnetic, they're electrical. This is a place where conductive surfaces behave strangely, where currents can be induced from distance, where solar particles spiral in loops and collide with high energy into everything that enters. It's also where observational clarity fades. Jupiter's magnetic field doesn't just distort particles, it obscures signals. Radio transmissions bounce, infrared signatures bend. And for Earth-based instruments, the moment 3i Atlas enters this field, our visibility begins to dim, which raises a chilling possibility. If an object wanted to cloak itself, reorient, shed debris, activate shielding, or even alter form, Jupiter's magnetosphere would be the perfect place to do it, a space large enough to hide in, energetic enough to power systems, and turbulent enough to mask anything subtle from our sensors. It's not just speculation, there's precedent. In 1995, the comet Shoemaker-Levy 9 broke into fragments under Jupiter's gravity and disappeared inside its clouds in a dramatic cascade of impacts. But not everything that approaches Jupiter breaks apart. Some things, especially interstellar things, emerge with new direction, with altered spin, with unexplained changes in brightness and structure. That's what scientists are watching for now, because if 3i Atlas performs another maneuver, if it curves again, pulses again, or ignites a new jet after entering Jupiter's domain, then it means this object isn't just being affected by the environment, it's interacting with it. And if it's interacting, then we're no longer tracking a comet. We're watching something that reacts to planetary fields with precision, something that uses the largest planet in the solar system, not as a dead end, but as an interface. An invitation has been sent. And 3i Atlas is answering. It's one of the first things you learn about comet physics. The sun heats the surface, ice turns into gas, gas escapes into space, and the force of that release pushes dust and vapor away from the sun, always away. The tails stretch out in the opposite direction. The jets, if visible, usually trace that same path, outward, reactive, chaotic. Comets don't push back against the star that's heating them. They retreat from it. But 3i Atlas didn't get that memo. From the earliest high-resolution captures taken after its solar approach, one detail stood out. A jet not pointing away from the sun, but almost directly toward it. Not subtly curved, not veiled by plasma diffusion. A clean, focused jet with mass and momentum being expelled in the wrong direction. This single observation disrupted every standard expectation about what this object should be doing. Initially, astronomers labelled it a venting anomaly, a surface irregularity, perhaps a deeply embedded volatile deposit near the sunward side that just happened to erupt after perihelion. Maybe the object rotated in a strange axis. Maybe there was an albedo variation causing uneven heating. All possible, all plausible, but not enough. The jet didn't blink out after a few hours, it didn't curve, it held. And as Earth-based observatories continued tracking the object beyond December 19th, the sunward jet remained. It pulsed, but it didn't pivot. It flared, but it didn't fragment. It remained aligned like a thruster, targeted, continuous, and geometrically consistent. And then the trajectory shifted. The course deviation that began after the Earth flyby wasn't random. It matched the vector you'd expect if that sunward jet was doing something deliberate, pushing the object in the opposite direction, subtly adjusting its outbound angle, nudging it from a generic solar egress to a precise new path. Jupiter's orbital plane. That's not outgassing. That's propulsion. And here's where it gets even more compelling. For the physics to work, the ejection velocity and mass flow from that jet would need to exceed normal comet values by orders of magnitude. We're not talking about light puffs of vapor escaping into space. We're talking about sustained directional momentum, on par with what a low-thrust spacecraft might use to navigate gravitational environments, with minimal energy expenditure. A kind of interstellar impulse, a slow, quiet burn. Except this isn't a spacecraft. Not officially. Not yet. But comets don't do this. The images from amateur and professional telescopes alike show no secondary jets that would account for spin correction or balance. No visible tumble, no irregular torque. If this was a natural eruption, it should have induced wobble. But the object stays balanced, the coma remains stable, the outflow is directional, tight, consistent, repeatable. At the European Space Agency, analysts quietly fed this jet data into solar sail simulations. The results were unsettling. The vector of thrust combined with the timing and trajectory shift mirrored precisely what you'd expect from a reactive body, one that wasn't simply expelling mass randomly, but using controlled ejection to navigate post-encounter drift. In other words, a jet with intent. Even more unusual, the temperature readings from the object's sun-facing surface didn't rise in accordance with the flare and jet activity. Instead, they remained relatively flat. Either the surface is shedding energy at an extraordinary rate, or the energy is being diverted internally, perhaps stored, perhaps transformed. So what kind of object ejects mass toward the star that should be destroying it, and then turns that force into propulsion? The only models that accommodate this behavior are not comet models. They are spacecraft models. They are energy budget systems with active outflow control. They are interstellar designs optimized for quiet maneuvering. And that sunward jet, it may not be a mistake. It may be the key. Because to reach Jupiter, to pivot cleanly into a new path, to hide among the gas giant's magnetic veil, something had to push this object with subtlety. Slowly enough not to disturb detection, but precisely enough to get there. That's what the jet is doing. Not venting, navigating. 2 nights after the Earth flyby, something flickered in the tail of 3i Atlas. At first, no one noticed. It was subtle. Too subtle for large-scale alerts or public bulletins. But in 3 separate regions on 3 different continents, a handful of amateur astronomers captured something strange in their long-exposure sky scans. A ripple, a motion, a wave that didn't match the movement of background stars or the ambient motion of the ion tail. It wasn't flowing outward like debris. It was moving inward, toward the object. And it aligned with a trajectory that, until now, hadn't been discussed. Jupiter. The images weren't synchronized. They came from Argentina, Italy, and a small observatory in British Columbia. Each one showed a narrow, angular shimmer within the coma, a linear pulse of brightness that travelled toward the nucleus, slow, narrow, and directional, and in each case, it lasted less than 7 seconds before vanishing. For days, the phenomenon was dismissed. Artifacts, lens flares, cosmic rays. Each explanation was reasonable. But what made those dismissals uneasy was that the angle of incidence where the ripple entered the coma was nearly identical across all 3 captures. And that angle was not random. It traced the arc that 3i Atlas was now following, the precise path leading toward Jupiter. So the question became not what the ripple was, but why it was arriving now. Earth's flyby was expected to mark the beginning of the outbound journey, a fading tail, a cooling body, an object drifting away from heat, light, and observation. But instead, 3i Atlas seemed to respond after the encounter, as if it had passed a threshold. Not a thermal one, but a trigger point. And once it crossed that invisible line, something inside it reacted. Something changed. The tail didn't fade, it intensified. The jet, still sunward, flared once more. And then, these echoes appeared, light rippling toward the object, not away. Like a wave being drawn in. That's not how comets behave. In standard models, the tail is a reactive plume, gas and dust escaping into space shaped by solar wind. It's the comet's past, not its future. But these ripples defied that narrative. They weren't fading memories of material already shed. They were incoming, travelling upstream. That reversal demands explanation. Some scientists have floated exotic particle reflections, solar wind bouncing off dense regions of the coma and creating backscatter. Others proposed magnetotail interference, where Earth's own magnetic field briefly distorted the object's trailing ion stream. But those theories fall apart under one detail. The light wasn't diffused. It was concentrated, thin, coherent, and it moved too quickly to be passive scatter, which brings us to the troubling interpretation. If 3i Atlas was waiting for the Earth encounter to end, if it was navigating a timing sequence, then what followed could be a signal, a handshake, a post-encounter instruction or input, the kind of downstream echo that only arrives once the first leg of a mission is complete. Because this ripple didn't resemble anything natural, it resembled a trigger. Some astrophysicists have compared it to the way deep space probes reorient after receiving new telemetry packets from Earth. A small delay, followed by a directional change, followed by internal reconfiguration. If 3i Atlas had an internal system, or even just an orientation algorithm, the ripple could have been its update signal, a spatial ping. A command that only activates once Earth is behind and the path to Jupiter is clear. And that's exactly what followed. Within hours of these observations, the object's course shifted again, not sharply, not erratically, but with precision, as if the signal had been received and the next phase had begun. It's tempting to think of Jupiter as a destination, a giant endpoint where an object like 3i Atlas might end its journey. But that's not what makes Jupiter important in this story. It's not the end, it's the junction. A relay point in the deep solar system, vast, magnetic, and perfectly positioned between the fading warmth of the inner planets and the frozen silence of interstellar space. This planet isn't just big, it's strategic. Jupiter acts like a gravitational hub. Its sheer mass, over 300 times that of Earth, bends trajectories, warps orbits, and draws in objects from every direction. For centuries, it has shaped the fate of comets, asteroids, and even planetary debris. In most cases, that means pulling something in and flinging it out, either toward the sun or deep into space. But in rare cases, it does something else. It holds objects, suspends them, alters their course, not chaotically, but with just enough force to make small, meaningful changes that can send an object anywhere in the solar system, or even out of it entirely. That's why some scientists aren't seeing Jupiter as 3i Atlas's final stop. They're seeing it as a pivot point. The current trajectory of 3i Atlas now places it on a path that intersects not Jupiter itself, but a narrow corridor trailing behind it, a gravitational eddy formed by the gas giant's orbit, one that often contains temporary moons, trapped debris, and occasionally strange orbital visitors. Why go there? Because it offers the perfect platform for another maneuver. If 3i Atlas wanted to use Jupiter as a slingshot, it wouldn't need to skim the planet's clouds. It would only need to approach close enough for the planet's gravity to pull it into that corridor, and then release it. But this release wouldn't be random. If timed correctly, it could redirect the object towards Saturn, Uranus, or even back inward, toward one of Jupiter's many moons, and it's those moons that raise the biggest questions. Among them is Europa, a world with a liquid ocean hidden beneath an icy crust. Then there's Ganymede, the largest moon in the solar system, and Io, a volcanic dynamo pouring plasma into Jupiter's magnetic field every second. These moons aren't passive rocks, they're environments, systems, places with magnetic footprints and thermal signatures, and now 3i Atlas is heading right through their domain. If this object is interacting with magnetic fields, and the polarimetric data near the Sun suggests it might be, then the space around these moons offers more than gravity. It offers opportunity. This is where interactions can occur without being detected, where plasma discharges and magnetic disturbances can mask anything short of a full engine flare, where an object can vanish, momentarily, from observational clarity. In mission planning, this is called an occlusion window, a moment when ground-based systems lose line of sight, and what happens next is hidden behind mass, energy, or signal interference. Jupiter is full of these windows, and 3i Atlas is about to enter one. But it's not just the magnetic possibilities that make Jupiter ideal, it's the mechanics. The planet orbits at the edge of the snowline, the boundary where solar heating weakens and icy bodies can preserve their internal chemistry. This makes it the perfect handoff zone, a place where outbound comets shed mass, and where inbound objects recharge, slow down, or quietly shift vectors. And if you were piloting something that needed to refuel, or to transmit, or to receive instructions, this is where you'd pause, this is where you'd reorient. Jupiter isn't the destination, it's the switchboard. And as 3i Atlas approaches, the real question isn't what happens when it gets there, it's what happens after it leaves. The first signal didn't come from 3i Atlas, it came from something else. At precisely 0311 UTC on December 24th, the European Southern Observatory registered a narrow band reflection near the orbital position of Ganymede, Jupiter's largest moon. At first, the observation was dismissed as a glint from Ganymede's surface ice, a common occurrence when sunlight reflects off its thick crust. But when the team ran a polarization analysis on the return light, they found something that didn't fit. The angle was wrong. The source of the reflection didn't align with the sun's position at the time. It wasn't bouncing directly off Ganymede. It was bending, deflecting, as if the reflective surface wasn't fixed, but instead moving, angled, responding to light like a mirror in motion. This dataset was correlated with concurrent observations from two other instruments, the LBT in Arizona and the Italian Galileo National Telescope. Both recorded the same brief flicker of directional light, lasting under 2 seconds, and both mapped the angle of origin within 1 degree of 3i Atlas's adjusted trajectory. This wasn't random. The light did not originate from Ganymede. It originated near it, somewhere in the orbital corridor behind the moon, somewhere in a space that, until now, had held only dust, debris, and electromagnetic haze. Something there had reflected light in a structured, directed way, and its angle matched the path of 3i Atlas. What followed was quiet. No official statement, no alerts. But several internal observatory teams began revisiting old assumptions, particularly the idea that 3i Atlas was heading for deep space after its Earth encounter. Because now, with this reflection, another possibility had emerged. Maybe it wasn't just heading to Jupiter, maybe it was aiming for something near Ganymede. If this object is more than a comet, if it carries geometric structure, conductive materials, or even active orientation systems, then reflecting light intentionally is not just possible. It's functional, it's communication. This wouldn't be the first time astronomers speculated about such behaviour. In 2017, the interstellar object Oumuamua exhibited an unexpected increase in velocity, one that couldn't be explained by standard outgassing. That acceleration was so clean, so low noise, that one hypothesis suggested it might be the result of solar radiation pressure, like a sail, not a rock. Now, with 3i Atlas, we're seeing something similar, only this time the reflection is directional. This time, the light points somewhere, and the timing is hard to ignore. It came after the Earth flyby, after the post-flyby jet, after the ripple in the tail. It came precisely as the object crossed into the outer magnetic boundaries of Jupiter's field, into a region known for electromagnetic distortion, interference, and observational blind spots. It came as 3 Atlas entered the only planetary environment in the solar system, large enough to contain multiple moons, thick radiation belts, and occlusion windows, places where an object can hide. If the reflection was intentional, if it was a pulse or a beacon, or even just a reply, then Ganymede is no longer just a moon. It's part of the sequence. Some now wonder if the object is using Jupiter's moons like nodes, stepping stones in a broader system, possibly leveraging their electromagnetic environments to guide itself, to relay information, or to receive some kind of interaction we don't yet understand, because the light from Ganymede wasn't diffuse. It was sharp, brief, aligned. And that alignment points back to 3I Atlas. It didn't answer with brightness. It didn't respond with jets. It reflected, like a mirror flashing a signal. And now, that signal is behind us, and the object, whatever it is still moving forward. Every object in space is influenced by light. Photons, though massless, carry momentum. When they strike a surface, they transfer a tiny amount of force. For most celestial bodies, this pressure is negligible, lost in the overwhelming scale of gravity and inertia. But under the right conditions, on the right kind of surface, light alone can move things. That's the principle behind solar sailing. The idea is simple. A large reflective surface, like a sail, catches sunlight and uses it to generate thrust. The photons don't push hard, but they push constantly. And over time, that push adds up. The Japanese space agency JAXA proved this with their Ikaros probe in 2010. It used nothing but sunlight to navigate space. No fuel, no rockets, just light. For decades, solar sails were science fiction. Now, they're real. And some scientists are beginning to wonder, what if 3I Atlas is using the same principle, because the behaviour matches? The post-Earth flyby course change was not sudden. It was smooth. A gentle curve, not the chaotic tumble of an outgassing event, but a controlled arc shaped over time. It lacked the randomness of natural venting. It lacked the rotational noise. It showed symmetry. When analysts plotted the trajectory shift against solar radiation pressure, something strange happened. The math worked. If you model 3I Atlas as a highly reflective surface with a low mass-to-area ratio, the change in direction aligns with the expected acceleration from photon pressure at that distance from the Sun. The numbers aren't perfect, but they're close enough to raise eyebrows. Too close for coincidence. And then there's the surface data. Polarimetry studies near perihelion showed negative polarization, light bouncing off the object in a way that suggests a smooth, metallic, or at least non-porous surface. That's not how comet dust behaves. Comet dust scatters light irregularly. It creates a positive polarization signal, not a negative one. But 3I Atlas gave us the opposite, a signal consistent with reflective materials. And reflective materials are what you need for a solar sail. Still, there's a problem. Solar sails are large. Even the smallest ones humans have deployed stretch tens or hundreds of square meters. And yet, no telescope has resolved a visible sail structure on 3I Atlas. No panels, no wings, no clear geometry. But maybe we're looking for the wrong kind of sail. What if the entire object is the sail? Some models suggest that if a body has a thin, wide geometry, like a pancake rather than a sphere, and is made of reflective or semi-reflective materials, it can behave like a natural solar sail without deploying anything. It doesn't need wings, it is the wing. And if 3I Atlas is constructed in this way, flat, thin, wide, it would explain the brightness variations. It would explain the lack of tumbling. It would explain the light pressure effect that seems to guide it through space. It would also explain the low outgassing signature. Because this object isn't shedding mass to move, it's responding to light. That kind of behaviour crosses a line. It suggests planning, design, not necessarily artificiality, but engineering. A form shaped by function. An object built not for decay, but for survival, for movement, for trajectory. And now it's moving again, toward Jupiter, along a curve that light alone could generate, if the surface is right. That's what solar sails do. They turn stars into engines. They convert light into velocity. And in this case, the trajectory of 3I Atlas looks a lot like navigation. Not passive, not reactive, intentional. From the beginning, 3i Atlas has defied the most basic principle of physics. Energy cannot come from nowhere. And yet that's exactly what the numbers seem to suggest. Every comet, every asteroid, every spacefaring object we've ever observed follows a balance sheet. It absorbs energy, usually from the sun, and releases it in predictable ways. Through light, through heat, through jets of gas. The math is elegant and cruel. What goes in must come out. But with 3i Atlas, the balance never closes. The inputs don't match the outputs. And as the object moves farther from the sun, that discrepancy becomes harder, impossible, to explain. Near perihelion, the excess could be rationalized. Solar heating was high, radiation was intense, perhaps the surface was unusually volatile, and the venting was temporarily supercharged. Perhaps. But now, 3i Atlas is moving away from that heat source. It has passed its closest approach to both the Sun and Earth. Solar flux is dropping, photon pressure is weakening. The thermal environment is cooling. Everything about its situation suggests a slowdown. And yet, the activity continues. The jets remain. The coma stays bright. The trajectory still shifts. If this were a standard comet, the outgassing would be tapering, the ice would be depleted, the tail would begin to thin and fade, but none of that is happening. If anything, the object's emissions have grown more stable, more directional, almost regulated, and this raises a question that no natural model can fully answer. Where is the energy coming from? Let's quantify it. To sustain the current outgassing rates, particularly of carbon dioxide, 3i Atlas would need to produce an enormous amount of kinetic energy. Gas escaping into space at high velocity requires acceleration. Acceleration requires force. Force requires energy. Even with the most generous assumptions about surface area and solar absorption, the numbers fall short. The total solar energy available at its current distance simply isn't enough to account for the sustained jets. So theorists looked inward. Could the object have internal heat? Residual radioactivity? Thermal inertia? Possibly. Some comets do retain subsurface warmth after solar exposure, but not for this long, and not at this consistency. Thermal lag produces a spike, a brief delay, not weeks of continuous symmetrical activity. What about stored chemical energy? Could 3i Atlas contain exotic ices or reactive compounds that release energy upon exposure to sunlight? In theory, yes. But again, the persistence is the problem. These reactions don't last indefinitely. They flare, they burn off, they fade. What we're seeing here is endurance. Weeks of sustained output, jets that don't sputter or fragment, energy release that looks managed, and then there's the structure of the jet itself. It's not chaotic, it's not flickering, it's not rotating randomly as we see in natural outbursts. The jet is fixed, focused. It points in one direction, consistently, even as the object continues to move. That kind of regulation suggests not just energy, but control, and the more we examine it, the more the energy problem looks like a systems problem, because something is supplying power. If it's not solar, and not chemical, and not residual heat, then what's left? Some have proposed electromagnetic interaction with Jupiter's magnetosphere. It's possible that, as 3i Atlas enters this region, it could be drawing energy from the ambient plasma environment. Conductive surfaces could convert that flux into localized currents, producing thrust or heating. But this would require extremely sensitive materials, substances we've never seen in comets. More than anything, it would require intention, and so we return to the same tension. The object behaves like it's harvesting energy, not simply receiving it passively, but using it, directing it, turning it into motion. And if that's true, then we're not observing a comet anymore. We're watching a system that doesn't follow the rules of passive debris. Because whatever 3i Atlas is, natural or not, it's powered. And that power isn't fading, it's only just beginning. There are only two types of objects in space that change course. The ones pushed by natural forces and the ones told to. With 3i Atlas, we've already eliminated the usual suspects. The solar wind, photon pressure, even gravitational nudges from passing bodies, they've all been accounted for. And yet something keeps modifying its path. Not violently, not all at once, but with small deliberate corrections that seem increasingly purposeful. Now the question is no longer how it's moving, but why. For years, astronomers have tracked the micro-adjustments of comets and asteroids, always looking for the telltale signs of outgassing, rotation, or momentum change. Most are random, the result of uneven heating or surface shedding. But with 3I Atlas, the adjustments occur with eerie symmetry. One side vents, the other side stabilizes. The orientation shifts, but only slightly. The velocity changes fractionally. But the sum of these actions? A deviation from expected orbit, one that puts it on an increasingly complex route. And that brings us to a stunning possibility. What if it's being reprogrammed? The word sounds digital, human, artificial, but in a purely functional sense, reprogramming simply means altering a path, behavior, or outcome based on new instructions. Whether those instructions are stored on board, relayed from an external source, or generated through autonomous learning, doesn't matter. What matters is that the object is not locked into a fixed trajectory. It's learning, or reacting, or both. Just weeks ago, its trajectory carried it toward Earth. Then it bent, shaving past our planet, swinging closer than many predicted. Now, the curve is tightening again, this time bending toward Jupiter's vast domain. Was that decision encoded from the beginning, or was it triggered by something that happened during its flyby? Some scientists are quietly suggesting that 3I Atlas behaves as if it received an update. Not a digital packet in the way we send software commands, but a functional stimulus, an input that caused a change in behavior. Could electromagnetic conditions near Earth have been a trigger? Could it have encountered a specific field, a density, a temperature threshold that activated a new phase? We've seen similar things in engineered systems, space probes that reboot when entering new environments, or dormant systems that awaken after detecting solar light, but never in comets, and certainly never in deep space objects crossing interstellar boundaries, unless, of course, 3I Atlas isn't a traditional comet at all. The reprogramming theory hinges on one major detail: temporal coherence. If the object changed course in response to something and did so with a delay consistent with a processing or decision-making system, then we're not talking about a passive reaction. We're talking about logic, cause, and choice. Let's walk through the timeline. First, it passed Earth and entered a relatively quiet part of the solar system. Second, within 48 hours, subtle changes in its velocity profile were detected. These changes did not match solar wind fluctuations or gravitational pulls. Third, the anti-tail shifted, precisely, and in a way that adjusted the object's momentum. Fourth, deep space radio frequencies registered short symmetrical spikes in the vicinity of the object. No signal was confirmed, but the spike itself was odd, too sharp, too localized. And fifth, its new heading pointed directly toward a gravitational waypoint that offers slingshot potential around Jupiter. 5 actions, 5 data points, one trajectory that no longer seems accidental. If 3I Atlas is following a sequence, if these shifts represent a form of reprogramming, then the implications are profound. It means the object either contains an internal logic that activates at key spatial thresholds or is being guided step by step by an external protocol. Either way, it's no longer following the natural flow of gravity alone, it's navigating, or being navigated. And in either case, we have to stop calling it a comet. Wakes are not supposed to form in the vacuum of space the way they do in water. And yet, trailing behind 3I Atlas, beyond its tail, beyond its coma, there's a thermal disturbance that keeps showing up. It isn't smoke, it isn't gas, it's not even ionized particles in the traditional sense. What researchers are observing is a lingering heat signature, structured and persistent, that refuses to fade with distance. It behaves like a wake, but it's far too organized. Comets usually display chaotic trails of material as they shed volatile compounds, carbon monoxide, carbon dioxide, water ice, into space. The sublimation of these ices under solar radiation releases clouds of particles that expand outward and trail behind the nucleus in irregular, often asymmetrical formations. These are typically cold, fast, and ephemeral, not hot, and certainly not structured. But the data from 3I Atlas tells a different story. Infrared telescopes trained on its path have consistently picked up temperature anomalies stretching thousands of kilometers behind the object. These are not just residual signatures. They form a narrowing cone of warmth, with the object at the apex. Think of it like the wake of a speedboat slicing through a lake, but replace water with the thermal fabric of space. And now that fabric appears disturbed in a pattern that suggests directionality, propulsion, and interaction. What's even stranger is the heat persistence. Unlike natural outgassing, which dissipates rapidly, the thermal line behind 3i Atlas remains coherent for hours, even days after passage. Instruments aboard deep space observatories report gradients that don't align with solar energy distribution. In plain terms, it's staying warm where it shouldn't. Which raises a profound question. What is generating the heat? There are three possible sources. 1. Internal friction or energy release from within the object itself, but this would require a core far more active than any known comet. Even Oumuamua, with all its strangeness, never displayed a sustained thermal wake. 2. Some form of sustained venting or propulsion system, akin to a jet or reactor, though we hesitate to use those words without hard proof. This theory assumes that the object is not just passively reacting to the Sun, but actively modifying its environment. And 3, and this is the most unsettling, a field effect. That is, 3i Atlas might be manipulating space itself in a way that generates heat through interaction, not emission. We've never seen this in nature, but some physicists speculate that exotic materials moving through a plasma-rich solar medium could in theory generate localized disturbances that present as heat. Still, no one is claiming that outright, not officially, but if this thermal wake continues to expand in complexity, we may be forced to rethink how we define a comet's trail. Because right now, the wake behind 3i Atlas resembles something closer to a directed energy path, a signature not of chaos but of control. Some have pointed to the shape. The wake isn't ragged, it's not spreading evenly, it's tapering, narrowing, almost like a track being laid into space. That's not what heat does when it escapes, that's what heat does when it's guided. And as 3i Atlas continues toward Jupiter, this wake is bending with it, suggesting not only persistence, but coherence across spatial turns. Like it's not just the remnant of past activity, but the byproduct of something ongoing. So we ask again, what kind of object leaves behind a thermal trail that behaves like it was designed? Comets don't, rocks don't, debris doesn't, but machines might. For decades, Jupiter has been considered the solar system's most powerful magnet. Its magnetosphere, over 20,000 times stronger than Earth's, is a sprawling, violent field of charged particles and electric currents. It protects the gas giant from solar radiation, traps high-energy electrons, and generates powerful auroras at its poles. In many ways, it acts as a planetary shield and a sentinel. But something changed when 3i Atlas approached. The first indications came from Juno, NASA's long-orbiting spacecraft circling Jupiter since 2016. On December 13th, its magnetometers detected a sudden compression of the magnetosphere on the sun-facing side. At first, mission analysts assumed it was the result of a solar wind surge, normal behavior during coronal mass ejection events, but there was no corresponding solar flare, no CME, no elevated solar wind velocity detected by Earth-based or L1 probes. It wasn't coming from the sun, and then the compression reversed, but not randomly. The magnetosphere began to distort laterally, stretching not along the solar axis, but toward the exact coordinates of 3i Atlas's inbound trajectory. This was not just gravitational influence. Jupiter's magnetosphere, unlike its gravity field, is not easily pulled or shifted by small objects, even fast ones. In fact, for such a reaction to occur, the source would need to be emitting powerful electromagnetic interference, possibly even generating a field of its own. Which brings us to the anomaly. As 3i Atlas drew closer to the outer edges of the Jovian system, the distortion in Jupiter's magnetosphere grew more defined. Auroral emissions spiked, radiation belts thinned, and then reformed in new configurations. Instruments aboard the European Space Agency's JUICE probe, currently in pre-encounter alignment, reported a lateral drag on high-energy particles, a pull that defied expected trajectories. It was as if the entire magnetosphere was shifting not from within, but from without. Some researchers began comparing these effects to what occurs when a moon like Io interacts with Jupiter's field. Io's volcanic activity generates vast quantities of charged particles that flood the magnetosphere and cause distortions, But 3i Atlas isn't volcanic, it isn't in orbit, and it's not even inside Jupiter's system, at least not yet. Still, the behaviour mirrors it. And then came the radio spike, across multiple observatories, Parkes in Australia, Arecibo's successor array, and the Allen Telescope Array in California. An unusual broadband burst was detected originating near Jupiter's magnetic equator. It was short, sharp, and modulated, not in the random frequencies of natural emissions, but in a layered, structured format, one that repeated, then stopped, as if triggered by proximity. We've seen Jupiter emit powerful radio waves before, especially during moon alignments or energetic solar events. But this one was different. It matched no known profile, and it occurred within minutes of 3i Atlas crossing the boundary of Jupiter's bow shock, the outermost limit of the magnetosphere. That's when researchers began drawing parallels to controlled systems, because what we're seeing looks less like a natural reaction and more like two fields communicating. Could 3i Atlas be emitting its own magnetic or electromagnetic field? If so, it may be far more than a comet or interstellar object. It may be using the interaction with Jupiter to probe, to manipulate, or even to alter the planet's massive energy environment. And if that's the case, it would mean 3i Atlas is not just targeting Jupiter's gravity well, it's targeting its magnetic field. For what purpose? We don't know. But the implications are vast. If you can change Jupiter's magnetosphere, you can alter how radiation moves in the solar system, you can influence moons, you can trigger energetic releases, or suppress them. It's like poking the control panel of a nuclear reactor. And the signal that just came through, some think it was a test, others fear it was a message. Auroras have always been one of the most breathtaking manifestations of planetary magnetism. On Earth, we call them the northern and southern lights, ribbons of colour spiralling across the polar skies, triggered when charged particles from the solar wind collide with atmospheric molecules. But on Jupiter, the auroras are different. They're larger, more intense, and they don't wait for solar storms. Jupiter's rapid rotation and strong magnetic field generate auroras constantly, complex rings of energy dancing around its poles. But something else has started happening. As 3i Atlas neared Jupiter, the traditional polar auroras began to shift, not just in brightness, but in location. Observatories tracking Jupiter in the infrared and ultraviolet bands, including NASA's Hubble Space Telescope and Japan's Hisaki satellite, began reporting auroral flares away from the poles. In several cases, the emissions appeared closer to the equator, a region where auroras are not supposed to occur. At first, scientists suspected instrument calibration errors. After all, auroras outside the polar regions had never been documented on Jupiter or any other gas giant at this magnitude. But the data held firm. Then, ground-based telescopes in Hawaii and Chile, using narrow-band filters, confirmed the same thing. Streaks of energetic particles igniting the upper atmosphere at latitudes between 20 and 40 degrees. That is not just rare, it's physically anomalous, because it violates our understanding of how auroras work. On Earth, magnetic field lines funnel energetic particles toward the poles, where the field lines converge. That's why auroras are so tightly bound to high latitudes. The same logic applies to Jupiter. So for auroras to appear in equatorial or mid-latitude zones, the field lines must either be radically distorted, or something else must be injecting particles directly into those regions. This brings us back to 3i Atlas. Just before the anomalous auroras appeared, Juno detected a spike in energetic particles entering Jupiter's middle magnetosphere. These weren't from the Sun. There was no CME, no solar trigger, no increase in heliospheric activity. Instead, the source vector pointed away from the Sun and toward the region where 3i Atlas was approaching. It was as if the object had reached a tipping point in its interaction with Jupiter, just enough proximity to begin disrupting or interacting with the planet's energetic systems, like a tuning fork vibrating near a resonant frequency, triggering waves across the field. And then came the ultraviolet signature. For the first time, an auroral arc was observed travelling, not statically pinned to a polar region, but drifting across latitudes, tracing a path from high to mid to low, and then vanishing. This dynamic movement had never been seen on Jupiter. It wasn't just a shift in brightness, it was a relocation. Some researchers theorize this could be a side effect of field line reconnection, a process where magnetic field lines break and reform, transferring massive amounts of energy. But even then, reconnection happens in specific zones, not here, not across entire latitudinal bands. That leaves us with a chilling possibility. If 3I Atlas is emitting electromagnetic pulses or carrying a field of its own, it may be drawing Jupiter's auroral activity toward it, or using it as a medium of interaction. In that case, these equatorial auroras are not accidents, they're responses to an intruder. If confirmed, this would be the first recorded instance of an auroral shift not caused by solar activity, magnetospheric interaction with a moon, or rotational currents, but by an external interstellar object. And if it can do that to Jupiter, what might happen if it nears Earth? Not by distance, but by influence. Because if it can make Jupiter's auroras move, it might also know how to move them, or worse, what they're hiding. Europa has always stood out. Among Jupiter's dozens of moons, it's one of the most studied, not for its surface, but for what lies beneath it, a subsurface ocean trapped under an icy shell, harbouring the potential for life. Scientists have long suspected that under Europa's cracked and chaotic crust lies a salty ocean kept liquid by tidal forces from Jupiter's immense gravity. It's a world of possibility, a moon that breathes through its ice. But something just changed. Roughly 48 hours after 3I Atlas completed its flyby of Jupiter, the European Space Agency's JUICE mission recorded an unexpected tremor in Europa's orbital behaviour. It was subtle, an uncharacteristic oscillation in Europa's spin rate and axial tilt. While such fluctuations can be attributed to tidal flexing, this one didn't follow the known gravitational patterns. It was off-phase, asynchronous with both Jupiter's tug and Europa's orbital resonance with Ganymede and Io. In other words, the wobble shouldn't have been there. The data came in from multiple instruments: JUICE, Juno's magnetometer, and Earth-based interferometry systems monitoring radio signals from the Moon. They all indicated the same thing, a momentary but distinct disruption in Europa's alignment. The Moon had trembled. Then came the plume. The Hubble Space Telescope and the James Webb Space Telescope, working in parallel observation mode, picked up a column of water vapour shooting from Europa's southern hemisphere. While Europa is known to exhibit plumes from time to time, these geysers usually erupt near its equatorial fracture zones. But this one was different. It originated near the ice ridges closer to the pole, and the velocity of the outburst exceeded any previously recorded geyser. The most alarming part? It occurred seconds after the recorded orbital tremor, as if something deep within the Moon had shifted, and the ocean beneath had pushed back. Geophysicists began rerunning internal models, trying to simulate what could cause both an orbital disturbance and a geyseric eruption. Their simulations failed, not because of bad inputs, but because the energy spike required did not align with known planetary interactions. There was no internal reason for the event, which leaves only one possibility: something external. And all eyes turned to 3I Atlas. Its trajectory, although distant from Europa's orbital path, had placed it on a vector that intersected with Jupiter's magnetic field lines that thread through the Galilean moons. If 3I Atlas was emitting bursts of charged particles or gravitationally interfering through its unexpected mass, or both, it could have sent a pulse into the magnetospheric lines that connect Jupiter to its moons. This would be unprecedented. It would imply that 3I Atlas didn't just affect planets. It could reach into moons, displace their internal energy, and trigger physical responses in completely separate bodies. The Europa disruption event, as it's now being called in academic circles, could mark the first time in recorded history that an interstellar object caused a geological shift in a moon other than Earth's. There's one final detail. Hours after the plume eruption, radio astronomers listening to Europa's emissions recorded an unusual signal spike. An electromagnetic pulse at an oddly consistent frequency, one that tapered off over 32 minutes before vanishing. It wasn't regular radio noise, it wasn't Jupiter, it wasn't solar interference, it was a pattern. And it emerged after the disruption, like a resonance or an echo. No one knows if it came from Europa or if it passed through it. But now, mission analysts have fast-tracked new proposals to point more instruments at the Moon. Because Europa may no longer be just a passive icy world, It may have just been touched, nudged, twisted, forced to respond by something that's not supposed to care. And if 3i Atlas can do that to Europa, what else is it capable of? Ganymede is not just Jupiter's largest moon, it is the largest moon in the entire solar system, even bigger than Mercury. But unlike other moons, Ganymede has something rare, its own magnetic field, a self-generated magnetosphere that pulses independently of Jupiter's vast electromagnetic domain. It's a kind of quiet defiance, a moon that claims autonomy in a system ruled by giants. But that defiance may have just been tested. 2 days after the Europa disruption event, several observatories began noticing strange flickers across Ganymede's northern hemisphere. Not optical flickers, but magnetic ones. Intermittent, surges in localized flux density, particularly near the groove terrain known as the Galileo Regio. It was subtle at first, then it intensified. The ESA's JUICE orbiter, which had already been transmitting telemetry from Europa, swung into range and picked up something peculiar. Surface-level flux eruptions, bursts of electromagnetic activity pulsing from Ganymede's crust in organized rhythmic intervals. This was not normal. Magnetometers aboard JUICE and synchronized instruments on Earth detected clear modulation, as if something beneath the icy surface of Ganymede was generating pulses at measured repeating frequencies. These pulses weren't random. They came in sets of 7, followed by a silence window of 32 seconds, then resumed. The rhythm held steady for nearly 2 hours. What could cause that? Scientists first suspected solar wind variability, but the sun had been stable during that window. Solar observatories confirmed a quiet patch in heliophysical activity. Others blamed Jupiter's influence, but Jupiter's own magnetosphere was calm, no bursts, no anomalies. And even if there had been, Ganymede's magnetosphere is partially shielded by its own field. Eventually attention turned again to 3i Atlas. Just as the comet-like object had triggered oddities near Europa, it now seemed to be resonating, directly or indirectly, with Ganymede. Analysts ran orbital reconstructions and found that 3i Atlas had passed through a dense corridor of Jupiter's plasma sheet just hours earlier, one that extends into the outer boundaries of Ganymede's influence. Here's where it gets stranger. Infrared sensors on JUICE picked up temporary thermal flares on the surface. In one particular region, a 90 square kilometre zone flared several degrees warmer than the surrounding crust. And then, just as quickly as it appeared, it vanished. The surface returned to equilibrium. No impact crater, no gas plume, no residual heat. Just a brief warming, like something had passed through, not above. This has led to a startling new hypothesis: flux tunneling. Some physicists now propose that 3i Atlas may not be emitting electromagnetic energy in a wide field, but rather in directional beams, focused, highly coherent pulses that can interface with local magnetic fields. If true, it means Atlas could have deliberately or incidentally tagged Ganymede's magnetic signature, resulting in localized reactions. These are not just atmospheric interactions, they are surface-level responses, magnetic stress manifesting in the crust, heat blooming through ice with no visible cause, rhythmic pulses that hint at an underlying structure. It's not just a comet anymore, it's something that interacts. Back on Earth, radio observatories reported brief sideband interference on frequencies tuned to Ganymede's natural emissions. Again, it wasn't noise, it was structured interference, a beat-like echo that matched the modulation frequency seen in the flux pulses, and then silence. No more flux events, no more pulses. Ganymede returned to its quiet, frozen state, but for that short window, less than 2 hours, something moved through its field, through its surface, and left a trace, not a scar, a pattern. Researchers are now calling it the Ganymede flux event, and it raises a chilling possibility. If 3i Atlas can stimulate activity inside a moon's magnetic field, if it can touch crustal temperature without impact, if it can broadcast structured pulses, then it is not just reacting to the solar system, it may be scanning it. While Jupiter's moons were the immediate recipients of 3i Atlas's proximity, they weren't the only bodies paying attention. Millions of kilometers away, orbiting a quiet and unassuming red world, an entirely different detection occurred, one that wasn't expected, and one that may represent a breakthrough in understanding the comet's underlying behavior. This signal did not originate on Mars, it was reflected. On board the Mars Reconnaissance Orbiter, the Sharad instrument, normally tasked with scanning subsurface layers of the Martian crust using radar, picked up a brief anomaly. It wasn't part of its scheduled operation. The detection occurred during a passive window when the radar was idling, pointed toward the northern ice cap. But in the data logs, a spike emerged, an electromagnetic pulse, tight in bandwidth, passing across the Martian orbit from deep space. Engineers first assumed it was an artifact, a burst from solar activity, a glitch in equipment, or residual interference from Earth-based telemetry. But the signal didn't match any solar profile, and when they cross-checked with instruments aboard Maven, another Martian orbiter tasked with studying the planet's magnetosphere, they found a mirror anomaly, the same pulse, at the same timestamp. Only this time, Maven's data revealed something more. The pulse was reflected. In simple terms, the pulse didn't originate from Mars, but it bounced off the Martian surface. Specifically, it hit the upper atmosphere, refracted slightly, and continued on its path toward the inner solar system. Multiple probes detected the echo, including ground-based arrays back on Earth, albeit attenuated and filtered through the ambient electromagnetic noise of the Sun. The profile of the pulse was clean. It lasted exactly 2.4 seconds. It featured two peaks, spaced exactly 1.2 seconds apart. The frequency band was tight, centered around 300 MHz, and critically, it matched the same frequency profile detected earlier near Ganymede during its flux events. This consistency raises profound questions. For the first time, scientists now had data showing correlated emissions across planetary systems, not random electromagnetic spikes, but structured signals with timing, frequency, and resonance, all pointing to a common source. And that source was now indisputably 3I Atlas. More surprising, however, was the angle of incidence. Modelling the geometry of the reflected signal showed that it arrived from a direction tangential to Mars's orbital path. Not from the Sun, not from Earth, but from the outer sector of Jupiter's domain. In other words, the pulse was on a return trajectory, echoing back after initial contact. Scientists began running simulations. Could this be natural? Could an object like 3I Atlas, under the right conditions, emit a beam of electromagnetic energy that would strike Jupiter's moons, reflect through Ganymede's magnetosphere, and then ricochet toward Mars? The numbers didn't support it. Natural cometary behavior does not include coherent directed emissions, nor does it include the precision necessary to generate pulse reflections across planetary distances. Something else was happening here. One hypothesis emerged: 3I Atlas is scanning, but not with telescopes, not with visual instruments, with magnetotelluric methods, using planetary fields and reflective atmospheres to bounce pulses, gather echo profiles, and possibly map structural features across the solar system. This isn't fiction. Military-grade Earth-based technology already uses similar methods. Deep Earth radar that scans mineral structures by emitting pulses and reading back waveforms. Could 3I Atlas be using our planets in the same way? Could Mars have just been one mirror in a much larger solar system-wide scan? The idea is radical, but the data aligns, and now teams at the European Space Agency and NASA are working to model what 3I Atlas might have seen in its Mars reflection. If the pulse was sent deliberately, then what information did it retrieve? Was it aiming for something beneath the Martian crust? Was it trying to determine planetary composition? Or was it just confirming that someone, or something, is listening? It started as a leak, an anonymous upload to a private astrophysics forum, buried under gigabytes of unrelated data dumps. At first, no one paid attention. It looked like a malformed telemetry file. Raw numerical sequences, scrambled headers, some unstructured packets from what appeared to be deep space radar observations. But then a pattern emerged, hidden in the timestamps and coordinate references. The data was not from a telescope. It was from a military satellite, classified. More specifically, the data originated from the Space-Based Infrared System, or SPIRS, a network of United States Air Force satellites designed to detect missile launches and infrared anomalies from orbit. SPIRS doesn't normally get involved in comet observation. Its job is terrestrial, defensive, locked on Earth. And yet the leaked file was clearly tracking something else. Something in deep space, moving rapidly, radiating infrared pulses in a pattern that matched only one known object. 3I Atlas, The file contained exact telemetry coordinates, thermal images, and something even more unusual, a series of spectral line breakdowns showing emissions in the far infrared and microwave bands. These aren't frequencies typically associated with natural outgassing or coma expansion. They're structured, narrow, and sequenced. Some lines repeated every 11 minutes, others flickered in bursts of 9, followed by a silent window, then a resumption at half strength. The envelope of these signals showed the same recurring harmonics that had previously been reported near Ganymede and Mars. In fact, when overlaid with data from the Hubble Space Telescope's side-channel captures, they matched perfectly. But here's where it becomes unsettling. The metadata in the SBIRS files show that this information was not meant to be public. It was tagged with NSA classification codes and was supposed to be routed only to specific command clusters, namely NORAD and a subsection of the US Space Force's Tracking and Analysis Division. The only reason it appeared in that forum dump is because someone within the system deliberately masked it, relabeling it under the header of a defunct weather balloon program. In short, someone inside wanted this data to be seen. Why? Because it shows that the US government has been monitoring 3i Atlas with highly advanced instruments and possibly, just possibly, knows far more than it has admitted publicly. The military-grade spectral breakdown suggests that the object has active energy zones, not just solar-heated gas, but regions emitting in structured, frequency-stable pulses. This kind of emission is almost impossible to fake. It implies one of two things. 1. That 3i Atlas contains a source of controlled energy. 2. Or that it is responding to observations, dynamically adjusting its emissions. Both options rule out a simple frozen interstellar object. Both options imply interaction, and yet the scientific community has received none of this data through official channels. No press releases, no peer-reviewed publications, no updates to the Minor Planet Center's logs. All the while, SBIRS continues to track it. Even more intriguing is the motion path this data implies. According to the infrared trajectory models embedded in the leak, 3i Atlas did not take the most efficient gravitational assist route after passing Earth. It diverted, slightly but measurably, toward Jupiter. This change is visible only in the heat signature, not in optical tracking, and it suggests a secondary propulsion event, possibly jet-based, but more likely internally modulated. This data shouldn't exist. It shouldn't be in civilian hands. But now that it is, researchers are passing every byte. Independent analysts in Germany and Japan have confirmed the packet integrity. There's no question, the data is real. Which leaves us with a much bigger question. Why was it hidden? Was it fear of public panic? National security concerns? Or simply the fact that what this data reveals goes far beyond current models of cometary behavior and far too close to something we're not ready to understand? One thing is clear. Someone out there didn't want you to see this, and someone else made sure you did. The signal was brief, just under 8 seconds in total duration. But in that narrow window of transmission, something irreversible happened. Something that no one had predicted, and no one, even now, fully understands. The moment the pulse was first detected, beamed outward from the tail region of 3i Atlas toward the outer solar system, a series of anomalies began to register across multiple observation platforms. Most notably, a sudden deviation in solar wind alignment, detected by the Solar and Heliospheric Observatory, SOHO, just milliseconds after the signal's conclusion. The flow of charged particles from the Sun, which had been stable for nearly 42 hours, twisted, subtly but globally. Magnetometer readings showed a kink forming in the Parker spiral, the Sun's magnetic field configuration, oriented not toward Earth, but toward Jupiter. At the same time, high-frequency radio telescopes in Australia and Chile recorded faint but highly structured reflections. These weren't echoes in the traditional sense. They were delayed spectral mirrorings, exact inversions of known Earth-based transmission frequencies, rebounding from somewhere in the direction of Jupiter's orbit. In real time, this appeared coincidental. In retrospect, it was the first sign that Jupiter had received the message, and then 3i Atlas changed. Not in its orbit, yet, but in its emission profile. Over the course of the next 4 hours, the composition of its tail began to shift. Spectrographs revealed a sharp decline in standard carbon chain molecules like CN and C2, which are typically abundant in active comets. In their place emerged previously undetected signatures, highly ionized argon, and even traces of krypton, two noble gases rarely seen in solar system objects. Unless under extreme pressure or exposure to artificial excitation, it was as if the tail was being scrubbed clean. Further analysis from the Hubble Wide Field Camera 3 showed the ionization plume tightening, forming a narrow spine, pointed directly along the axis of its new trajectory. It looked almost like a jet stream being prepared for acceleration. But more than that, it looked deliberate. And then came the optical shift. Images from the James Webb Space Telescope, which had been allocated a last-minute observation window, captured something nearly impossible. The leading edge of 3I Atlas, that is the side now facing away from Earth, began emitting a faint cyan halo, not in the visible spectrum but in the near-infrared. This glow pulsed in rhythm with the original signal's frequency envelope, suggesting that the object was now operating in a loop, repeating the same signature it had just transmitted. But why repeat it? And why direct that repetition toward the largest planet in the solar system? Planetary scientists now believe this was not a simple data burst. This may have been a targeting phase, a ping-like sweep, not to inform, but to locate and lock. In the hours following this event, Jupiter's magnetosphere itself began to shift. This wasn't something anyone expected. Jovian magnetic dynamics are typically robust, self-contained, and incredibly stable. But suddenly, the outer lobe of the magnetosphere contracted, as if something was interacting with its outer shell. Some hypothesized an invisible wake. Others believed the magnetosphere was responding to a shift in solar radiation pressure. But none of those explanations accounted for the timing, immediately after the signal, and coincident with 3I Atlas's tail reconfiguration. One theory is gaining traction. The signal may have been a call, and the tail's transformation a response to a reply. In this model, Jupiter was not the target, it was the relay. What happened after the signal suggests that 3I Atlas had been waiting for a reply from somewhere or something near Jupiter. And once that reply came, it began changing course, reconfiguring, and, perhaps most alarmingly, activating a secondary behavior set. From that moment on, every observable trait of the object began diverging from cometary norms. The shape of its coma, the chemical emissions, the jet symmetry, the rotational inertia. Something had answered 3I Atlas, and that answer appears to have changed everything. By the time 3I Atlas altered its tail orientation and began repeating its signal loop, astronomers around the globe had shifted their eyes, no longer just on the object itself but on Jupiter. The largest planet in the solar system had suddenly become more than a passive neighbour in this story. It had become a possible recipient, or worse, a partner, in the strange developments now unfolding. And then something was found. In the outer reaches of Jupiter's magnetosphere, nearly 80 Jovian radii from the centre, telescopic images revealed a stationary object. It had been overlooked for years, largely because it moved with Jupiter, matching its speed and trajectory so closely that it appeared indistinguishable from a typical high-altitude moonlet or background noise. But now, reprocessing infrared scans from the Wide Field Infrared Survey Explorer, WISE, and radar pings from Earth-based observatories, revealed that this wasn't a moonlet. It wasn't even moving on a natural orbital path. It was locked in place, defying orbital dynamics, hovering like a sentinel. Astronomers named it informally JX-RET, short for Jovian X reticle, due to its unusual grid-like reflection pattern. But it was what came next that sent tremors through the planetary science community. Unlike natural objects, which tend to emit chaotic reflection patterns based on irregular shape and spin, JX-RET emitted geometrically, consistent pulses, hexagonal bands, fading in and out at regular intervals. These bands didn't match any known mineral or surface reflectivity. They resembled synthetic lattice structures, almost like panels, or worse, arrays. NASA initially declined to confirm its artificiality, but internal documents leaked from ESA's tracking facility in French Guiana indicated that JX-RET had electromagnetic reflectivity properties inconsistent with any known asteroid, moonlet, or space debris. In short, it was not natural, but what shocked scientists even more was its apparent reaction to the 3I Atlas signal. Roughly 2 hours after the object near Jupiter had been identified, It blinked. That blink wasn't a camera artifact. It was confirmed across multiple telescopes on different continents. A single flash, lasting only 13 milliseconds, originated from JX-RET and echoed the exact same frequency pattern that had been emitted by 3I Atlas's tail just hours earlier. It was as if the object acknowledged the call, and that acknowledgement seemed to alter 3I Atlas's behavior again. The rotational speed of the comet, already increasing steadily, doubled as measured by rapid changes in coma density oscillations. More importantly, a new structure appeared, a sideward pulse beam, barely visible in ultraviolet, directed again, not at Earth, but toward Jupiter's equator. This was no longer a mystery about an inbound space rock. It had become a triangulated event, with 3I Atlas, the strange structure near Jupiter, and the gas giant's own magnetic field forming a kind of interplanetary lattice. What does it mean? One possibility: 3I Atlas wasn't just targeting Jupiter, it was linking with something already there, and that something was likely waiting. Some scientists went further, theorizing that JX-RET may have been dormant, parked in orbit for centuries or millennia, until a specific activation signal arrived. That signal, they now believe, came from 3I Atlas. And if that's true, it would mean the object near Jupiter was not placed there randomly. It had a purpose, a waiting function, possibly even a monitoring role. If 3I Atlas is transmitting, JX-RET is responding. And the terrifying question becomes, to whom? Who placed it there? Who built it? And why would it only activate now, after 3I Atlas passed Earth? Jupiter's orbit, long believed to act as Earth's cosmic shield, now sits at the centre of a triangulated mystery involving unnatural signals, optical behaviour defying physics, and an apparent stationary structure that refuses to follow gravity's rules. Whatever JX-RET is, and whoever made it, one thing is clear. Jupiter is no longer just a planet in this story. It may now be the stage, or worse, the trigger. As attention shifted from 3I Atlas to the mysterious object orbiting Jupiter, the scientific community remained acutely aware of one crucial fact. 3I Atlas had not yet completed its journey. And while deep space observatories tracked its broad trajectory, it was the smaller, more agile Earth-based telescopes that noticed the next twist. It started with a subtle movement in the tail, not a full reversal, not even a new outgassing jet, but something more refined and far more deliberate. Across facilities in Chile, Hawaii, and Australia, high-speed visual tracking began to show an oscillation, not in the direction of the tail itself, but in its internal composition. Through spectral filters, astronomers observed thin streamlines inside the broader tail moving in near sinusoidal curves. These curves weren't random, they were coordinated, and more than that, they were timed. Using timestamp overlays from 3 separate observatories, analysts discovered that the curves in the tail oscillated at exactly 22-second intervals, a pattern consistent across all locations. The implication was profound. Something inside the tail of 3I Atlas was pulsing in fixed rhythm. It wasn't just reacting to solar radiation pressure or interacting with Jupiter's magnetosphere. It was performing an internal action, like a biological system regulating its own temperature, or more ominously, like a device repeating a signal for transmission. The tail, once assumed to be chaotic and passive, was now behaving like a structured conduit, as if the outgassed materials had been pre-engineered to form a transmission corridor. Astrophysicists ran simulation models using software typically reserved for satellite communication arrays. The resulting pattern, the oscillation, the frequency, the trailing decay signatures, matched known behaviours of modulated beam transmissions. It was as if 3I Atlas had turned part of its tail into an antenna. But to send what? And to whom? When the models were reversed, interpreting the movement as a signal reception mechanism rather than a broadcast, another chilling detail emerged. The oscillation was aligned not with Earth or the Sun, but toward Jupiter's shadow plane, the exact zone in which the object JX-RET had been previously observed. In effect, 3I Atlas had adjusted its tail to face away from the dominant radiation source, our Sun, and toward the darkened sector behind Jupiter. That configuration would be nonsensical for any natural cometary behaviour. But for signal transfer, it would reduce solar noise and create a clean corridor for undistorted communication. Astronomers at the Subaru telescope in Hawaii confirmed that when the oscillations reached their peak, a spike in polarized emissions occurred, just at the edge of visible light. These emissions were faint but consistent, and more importantly, repeatable. The rhythm was uncanny. Every 22 seconds, a slight surge. Every fifth cycle, a deeper dip. Every third deeper dip, a subtle sideward shift in ion density, almost like a digital checksum signature. This wasn't noise. This was structure. Suddenly, comet tail, dynamics had to be redefined. No longer just reactive debris, the tail of 3I Atlas was behaving as if guided, either by internal machinery or by a previously unknown natural phenomenon that mimics intelligent design with alarming precision. ESA's communications lab in Darmstadt proposed an even more unsettling hypothesis. 3I Atlas may not have created the tail as a result of heating, but instead released it intentionally. The materials inside it, once believed to be inert dust and frozen gases, may include engineered elements, metamaterials designed to emit or amplify signals under specific conditions. In other words, the tail itself may have been the point all along. And its activation now, just after the object passed Earth and aligned with the Jovian object, raises one final possibility. 3I Atlas didn't just pass by Earth. It scanned, it emitted, it waited. And now it has started to speak. But the transmission is not meant for us. It's aimed at the shadow behind Jupiter, and whatever is out there, it just received the first pulse. No sooner had Earth-based telescopes confirmed the oscillating emissions from 3I Atlas's tail than a new anomaly appeared, one that wasn't expected, wasn't predicted, and wasn't supposed to happen at all. The deep space signal arrays began to echo. At first it was dismissed as interference, reflections off the ionosphere perhaps, or artifacts from equipment recalibrations. But the signature was too precise. The delay between 3I Atlas's emission and the returning signal was always the same. Not close. Exact. A fixed interval of 16 minutes and 31 seconds. What returned was not a mirror image of the original frequency, but something far more unsettling, a modulated response. Scientists at the Allen Telescope Array noticed that every third return pulse carried inverted phase characteristics, meaning the response was not passive. It had been altered. It was as if something had heard the signal and answered. The trajectory and delay placed the source of the echo directly behind Jupiter, specifically in the L2 shadow region, where sunlight is permanently occluded and radio noise from solar radiation is minimal. This sector has long been considered the perfect place for deep space listening platforms, or covert satellites. But as of now, no agency, NASA, ESA, Roscosmos, or CNSA, had claimed any instrument in that zone. That left only two possibilities. Either someone's hiding something behind Jupiter, or something else entirely is responding. The first detailed response analysis came from Jodrell Bank Observatory in the UK. After filtering solar wind interference, the team found that the return echoes had not only phase alterations but frequency shifts consistent with intentional Doppler variation, the kind used in communications encryption. In layman's terms, the return wasn't a bounce, it was a reply. The format was like nothing Earth's scientists had ever catalogued. No Morse, no binary, no pulse gaps in traditional frequency hopping. Instead, the response was based on harmonic interference, a structure more common to quantum entanglement modelling than radio. More curiously, it resembled something closer to musical resonance. Every signal echo from behind Jupiter ended in a trailing note, 3 tones, spaced precisely in frequency bands corresponding to D, F and A, when transposed to the audible spectrum. No one knew what to make of that. But the 3-tone signature remained consistent. D, F, A. It didn't match any known satellite beacon. It didn't align with any pulsar harmonics, and it didn't correlate with natural magnetospheric distortions, which meant one thing: intelligence was behind it. The decision was made to perform a triangulated rescan of Jupiter's L2 region, using 3 of Earth's largest radio observatories in unison: Arecibo's replacement dish array in Puerto Rico, FAST in China, and the South African Meerkat system. Each was instructed to record any anomalous emissions in real time during the next 3I Atlas signal burst. They didn't have to wait long. At 04:02 UTC, just after 3i Atlas performed its next tail oscillation, all three stations recorded a simultaneous echo from exactly the same coordinates. The delay remained at 16 minutes and 31 seconds, but this time the response included something else. An embedded frequency band, too high for human ears, showed logarithmic compression patterns. Those patterns matched no radio physics known on Earth. In a quiet room at NASA's Jet Propulsion Laboratory, one technician said what no one wanted to say aloud. "It's not just responding, it's processing." The silence that followed was broken by an email, flagged red and labelled Top Priority Orbital Position Shift. It came from the New Horizons spacecraft, which had just completed a long-range infrared scan of Jupiter's dark zone. There was movement, not from 3i Atlas, from inside Jupiter's shadow, a cold object, large, fast, and accelerating. Now 3i Atlas wasn't the only thing being watched. Something behind Jupiter had awakened, and it was moving forward. For weeks, scientists focused their attention on 3i Atlas, tracking its approach, decoding its emissions, and trying to explain its abnormal behavior. But now, the gravitational center of mystery had shifted. A new signal source, unconfirmed, unclaimed, and completely hidden until now, was moving out of the darkness behind Jupiter. The first clear image didn't come from an Earth-based telescope. It came from New Horizons. Though the spacecraft was never intended to track incoming objects from deep space, its long-range infrared instruments picked up a rapid temperature anomaly at the L2 shadow point. At first, it looked like noise, an error in the software, but the signal persisted and sharpened over the course of minutes. Temperature fluctuations revealed an object the size of a small moon, but its surface temperature was nearly absolute zero. That ruled out a comet or asteroid. Any natural body exposed to solar radiation, even behind Jupiter, would have residual thermal echoes, but this object had none. In thermal imaging, it appeared as a void, a cutout in the fabric of space itself. Soon after, the object began to move, and not slowly. Within 1 hour, it accelerated from a geosynchronous drift to a trajectory that was angled toward 3i Atlas's projected path. It wasn't heading to Earth, it was intercepting. NASA scientists began drafting contingency protocols, at first quietly, then under internal security classifications. This wasn't a comet anymore. It wasn't just about 3i Atlas. Something larger, faster and colder had just emerged. It was silent, it was coordinated, and it had a destination. Within hours, 3 more observatories confirmed the anomaly, each capturing its shift in position relative to background stars. But what shocked them most wasn't its velocity, it was its trajectory corrections. The object didn't arc gently like a natural body under gravity. It pivoted, with angles and speed that implied propulsion. Natural bodies do not pivot, only machines do. The object exited the shadow of Jupiter at 0644 UTC. For the first time, sunlight struck its form, but there was no reflection, no glint, no albedo. Instead, the light bent around it. Astronomers from the European Southern Observatory were the first to say what everyone was thinking. We're not looking at a surface, we're looking at a field. What that field was, gravitational, magnetic, or something unclassified, remained unknown. But it was clear that light did not behave normally around the object. Stars directly behind it warped and stretched, like heat waves bending distant roads, and then a second anomaly. A pulse, short, tight and localized, emerged from the object's flank. It wasn't radio, it wasn't visible, it was gravitational. LIGO, the Gravitational Wave Observatory in Louisiana, picked up a short spike. Something never before recorded in this sector. It wasn't caused by 2 stars merging. It wasn't a black hole. It was something small and dense, shifting space in a precise directed burst. That's when a pattern became visible. Every time 3i Atlas performed its tail oscillation, the object behind Jupiter responded, with gravitational pings. The two weren't just communicating, they were in synchronization. A deep space resonance had been established. 2 unknown objects, one approaching from interstellar space, the other hidden in our own system, now behaved like twin instruments tuning to the same frequency. And if they were instruments, then someone, or something, was playing them. Astrobiologists and theoretical physicists began coordinating models. One group proposed that the object behind Jupiter was acting as a gateway, A relay or receptor? Another group argued it was a monitor, a silent observer waiting for the right cosmic trigger. Either way, one thing was now certain. The second object had entered the game, and Earth was now caught between them. As the two mysterious objects, 3i Atlas and the cold, silent mass emerging from Jupiter's shadow, locked into a strange gravitational rhythm, something subtle began to shift back home. It started as a whisper in the instruments. Magnetometers stationed across the Arctic Circle, normally used to detect auroral activity and solar storms, began registering minute but synchronized deviations. At first, the readings were dismissed as background interference, perhaps fluctuations caused by solar wind or equipment drift due to winter storms, but the timing didn't match any known solar event. On December 18th, at Ödrumshubust 17 UTC, multiple magnetometer arrays across Greenland, northern Canada and Siberia picked up a coordinated pulse. Each one recorded an abrupt clean spike, then a drop, lasting less than half a second. Nothing like it had been observed before, not during geomagnetic storms, not during solar maximums, not even during coronal mass ejections. This pulse was different. It didn't originate from the sun. It was pointed, precise, and eerily aligned with the angular shift of 3i Atlas as it adjusted course post-Earth flyby. At NASA's Goddard Space Flight Center, the anomaly was fed into magnetic simulation models. And what emerged was even more troubling. The magnetic field surrounding Earth wasn't just shifting, it was resonating. Resonance implies rhythm, it implies pattern, and worst of all, it implies response. In other words, Earth's magnetic shield, normally a passive defense, was reacting to something. One possibility was immediately raised. If a gravitational pulse from the Jupiter object reached Earth indirectly through 3i Atlas, the magnetosphere may be caught in a feedback loop. The analogy: a wine glass vibrating when a specific frequency is played near it. Not because the glass is being touched, but because the vibration hits its resonant frequency. Now imagine that happening to an entire planet. Over the next few hours, the anomalies intensified. Magnetic north, normally a slow drifting point near the Canadian Arctic, experienced a jolt. According to data from the European Space Agency's swarm satellites, the pole moved several centimeters in just under 2 minutes. That kind of jump would normally take months to occur. Meanwhile, something stranger happened in the ionosphere. High-frequency radio signals, used by submarines and long-distance aircraft, began to scatter. Stations across the North Atlantic reported unexpected skips in frequency. Communications were bouncing unpredictably, as if being warped by an invisible lens above the atmosphere. At first, ground control blamed it on localized weather interference, but then South African observatories began detecting the same phase distortion, on the opposite side of the globe. Earth's magnetic field was not just resonating, it was being shaped, and the signature matched nothing in the space weather logs. Scientists began to suspect what they couldn't yet prove. Something external and intelligent was now interacting with Earth's magnetosphere, not attacking it, not disrupting it in chaos, but testing its resonance, like tapping the edge of a shield to see how it rings. The final confirmation came just before sunrise over the Pacific. From the Haleakala Observatory in Hawaii, astronomers caught a visual burst, barely detectable, of ultraviolet auroral glow forming outside the normal polar range. It shouldn't have been there, and then 1 frame later it was gone. Some argued it was a camera glitch, others weren't so sure, because in the exact moment the glow flared, 3i Atlas changed direction again, not sharply, but just enough to align with the predicted arc of the object behind Jupiter. That adjustment, precisely timed with Earth's magnetic resonance, pointed to a terrifying possibility. Earth wasn't just a waypoint in this encounter, it was a tuning fork, and whatever had caused that shift, whether 3i Atlas or the object behind Jupiter or both, was still playing the note. If this was just a comet, the story would have ended when it passed Earth. But 3i Atlas didn't vanish into the void. It didn't fizzle out or drift harmlessly into deep space. Instead, it pivoted, with purpose. It altered course toward the largest planet in our system, and now something else is moving with it. We saw gravitational shifts, auroral distortions, magnetic pulses that ripple through our instruments like a code waiting to be deciphered. And most disturbing of all, Earth didn't just observe these effects, it resonated with them. Every observatory now stares toward Jupiter, not with curiosity, but with unease. Because whatever changed 3i Atlas's behaviour may already be here, echoing through the magnetic field sliding beneath our satellites and whispering through the upper atmosphere in ultraviolet flares, and still, no agency has made an official statement, no scientist has declared certainty, because there isn't any, there's only the trail it left behind, and the direction it's going next. So subscribe if you haven't already, turn on notifications, because in the days ahead, we'll be tracking every shift, every pulse, and every silence. Because the silence may be the loudest message of all. We'll see you in the next episode. Stay curious, stay grounded, and don't stop listening.